B10, right? So this is one of those, thinking problems where it's like, well, what if we lived in an alternate universe where we had, different rules for the different quantum numbers? And so in this case right here, right, what the rule is that, in our universe, right, in our universe, right, the rules are that for n is just simply, right, 1 to infinity, right, any integer in that case. No. Um, right, L has the rule that it's then just simply from 0 to n minus 1, right, and then m sub L is going to have the rule then that it goes from minus L to 0 to positive L, right? That's in our universe. In this alternate universe, right, you still have similar rules, right? So we still have then the n, values can be from 1 to infinity, right? The L values now, though, are different, where instead of it going from 0 to n minus 1, we can go from 0 to n in this scenario, right? So we're going from 0 to n now. And then the ML values, right, are still going to be minus L to 0 to plus L, right? So the only thing that changed was the L value. So what that means then is that we can essentially access p orbitals already at the one state, right? So the configurations that you can have, right, you can have for orbitals, right, you can have the 1s, but you can also have the 1p now, right? Then here you can have the 2s, and then the 2p, and the 2d, right? You can have 3s, 3p, 3d, 4, not 4f, 3f. I was thinking back to our universe. 3f, right, and so forth, in those cases. And so what you can do is you can go through and essentially like assign everything. And so I know on the key I only really gave, the main group stuff. I didn't include the D, just because, like, if you can do the main group stuff right, then you understand what's going on with the D. But so in those regards, right, if you can have the 1s and the 1p, you can still have then, the configuration where you're going to have then in that first row, right, 2s2, 1p6, right? So you're going to still have then in that first row, right, if you look at the current periodic table, right, the first row only has 2 electrons because it only, allows the 1s. The second row then has the 2s and the 2p, but you can have the you can have 8 elements in that row, and so forth. And so if we go back to here, in these cases, and so what you can then do, right, is you can have your S row, right? So you can have, 2 that are there, and then you can have your 6 P elements essentially, right, all the way over here, right? So then that'll be 1, 2, 3, 1, 2, 3, 4, 5, 6, right? So you have those right there, and then now all we have to do is just simply fill in everything that we have from the table, right? So, right, so it's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, fluorine, neon, what is this, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, right? So that right there would be the the first 2 rows, right? And so you could also include the D's, right? So the D's would be over here, and then you would have 10 of those, right? And that would then start including the chlorine and the and so forth. in those cases and shift all of that stuff. Um, but that's right. If you can get to this part right here, right, I would assume that you'd obviously understand how the rest of it goes. Right. And so that's essentially right what the first two parts right there would look like. How would you expect right? So the next question is which elements would be the new noble elements, right? So in that case, it would be the oxygen row elements would become the new noble elements, so to say. In this case, how would you expect the reactivity of the different elements to change? Right. What was previously noble elements, right? So helium and neon, those now suddenly would actually have some type of reactivity, right? They would probably be very similar to the alkaline earth elements that we have in our universe, right? Because they could easily lose 2 electrons to form, a 2+ ion that could then interact with something. In terms of oxygen and sulfur, right? Those become now the noble elements. So those, you would expect those to be, relatively unreactive, and everything. So, you would expect those changes to happen. Which element, sorry, the next thing is which element would you expect carbon from your new periodic table to be most similar to in our current table, right? So looking at it, because, essentially it's 2 from the noble gas, from the noble configuration, right, from the full octet, right, we would expect carbon probably to act very similar to oxygen in our universe, right, in our current periodic table. Just because, right, it would be able to form 2- ions. In that case, right, the Z effective would probably be pretty similar in those cases. And so, you would expect similar-ish reactivity, right? It's not going to be 1-to-1, but it'll probably, be pretty, similar as similar would go in those cases. So, and then, right, I mean, it goes back to like ionization energies as well, right? Because you would still see that same trend that you have, with oxygen and going to sulfur in our, or not sulfur, to nitrogen in our universe, right? You would see that same thing between carbon and boron, because now, right, you're going from something that has, not a completely half-filled set to a half-filled set, whereas like in the case of boron, right, you would expect it to then, have that uptick, and so forth, and everything, right? So it would have a lot of similarities in those regards.